Welcome, viewer, to the second episode of the TitanBot video series. In this episode, we'll be making a bracket that will hold two rotary encoder sensors that will help us track the rotation of our wheels. We're in FreeCAD. Begin by creating a new file. We'll create a body and a sketch for that body, and we'll make that sketch on the XY plane. Begin by grabbing the Create Square tool, and we're going to make a rectangle along the x-axis. And we're going to make this rectangle symmetric around the origin. We're going to set the length of the rectangle to 94 millimeters. And we're going to set the width of this rectangle to 12 millimeters. Now we're going to add 3 holes. These are going to be used for screws that will come up through the base we made in episode 1. And we'll attach the bracket to our base. Let's make this center circle coincident with the y-axis. We can do that by using the Constrain Coincident tool. And we're going to make these two outside circles symmetric with respect to the y-axis. Lastly, we need to make these two outside circles collinear with the central circle. So let's select the center of both of those, and we will constrain them horizontally. So if you've got your circles set up correctly, they should move in this fashion. Alright, now we need to set the position of these circles. First, let's constrain the distance between the two outside circles. So we'll click the center of those two outside circles, and we'll set the distance between them to 63 millimeters. And then we're going to set the distance between the from the top of our rectangle to the center of our circle here. Just going to make sure you click that just right. We'll come off to the side, and we're going to set that to 4.5 millimeters. So now we've got 3 degrees of freedom left that we need to constrain. So we're going to start by setting the circles so they all have the same diameter. And we're going to set the diameter of these particular circles to 2.8 millimeters. And that now fully constrains our sketch. We can close this. And we're going to pad this out to 8 millimeters. Now we're going to create a feature on the top of this block that we've just created. So left click on the top and create sketch. And we're going to use the external geometry reference tool to grab that bottom line. And again, with the Create Square tool, we are going to create a rectangle just on the bottom half of this shape. We'll do a box selection on these two vertices, or we'll just click on them individually, and we will constrain coincident. Okay. We are going to set the height, or width rather, of this rectangle to 4 millimeters. And now this feature shape is fully constrained, so we can close it. And we're going to pad this one out to 5.87 millimeters. Reason for that odd number is we need to make sure that the sensors are measuring the direct center of the encoder disc that's going to be on the end of our dual shaft gearboxes. Alright, the next thing that we are going to add is we're going to add the holes on the back of this bracket that we will attach the sensors to. So we have 2 sensors. Each sensor has 2 holes. So we're going to create 4 holes here. We're going to make the outer 2 holes symmetric with respect to the y-axis. We're going to make the inner 2 holes symmetric with respect to the y-axis. And again, we're going to make them collinear. So we'll select the 2 outermost holes there, and we'll constrain them horizontally. And now we'll set the diameter of all of our holes so that they are the same. And now we need to set the distance between these holes. So we're going to set a gap between these 2 holes that match our sensor. So that's going to be a distance of 21 millimeters. And we're going to set the distance of our sensor from the edge of this bracket. And we're going to reference the top edge of the bracket we're building. And we're going to set that distance to 17 millimeters. And we also need to set the distance of these holes from the top of the bracket. We're going to set that to 3 millimeters. And now we've got 1 degree of freedom, so we need to constrain the diameter of our circle. Because we're going to be using a 3 millimeter bolt, we're going to constrain the diameter of these holes to 3.2 millimeters. Okay, so we're fully constrained here. We can close this sketch, and we're going to pocket this all the way through the bench. And so we can see that those holes went all the way through. So the next thing that we're going to do is we're going to create 2 insets just behind where the sensors are going to sit. These will allow the through-hole solder connections to have a little bit of space to allow the sensor to sit flush against the back of our bracket. We're going to reference the top edge of this bracket, and we're going to create 2 square pockets. We're going to make them equal to each other in length and in height. And we're going to make these pockets so that they are symmetric with respect to the y-axis. So let's set the length of the pocket to 13.5 millimeters. We'll set the height of the pocket to 5.75 millimeters. And we'll set the distance between these pockets to 25.5 millimeters. So our sketch is fully constrained, so we can close out of this sketch, and we're going to pocket this as a fairly shallow pocket at 2.3 millimeters. So the main features have been added to this bench to hold our rotary IR sensors. We're going to give some cosmetic fillet to the edge of this shape. And now we need to add some additional features. This bracket is going to serve double duty on the TitanBot. It's also going to help hold the rack that the battery will slide in and out of. So we have to add some features for that now. So again, we're going to click on this back face here, and we're going to add a sketch. We're going to begin by adding 2 circles. These circles will be used for screw holes to mount the battery rack on. We're going to make them symmetric with respect to the y-axis. And we are going to add 2 half circle shapes. We're going to do that with the Create Arc by Center tool. And we need to reference the bottom of this bracket here. So I'm going to use the External Geometry Reference tool. You can see that 2 magenta dots that just showed up. I'll grab my Arc tool, left click on that reference line, create an arc. I'm going to do the same on the other side of the y-axis. These shapes need to be close, so I'm going to grab the line segment tool, and I'm going to close both of these arcs. Now we need to set the distance for these shapes. Let's set the distance between our 2 circles that we created earlier. We're going to set that to a distance of 39 millimeters. And we also need to set the height of these circles above the bottom of our bracket. So we're going to set the distance there to 4 millimeters. And then we're going to make sure that our half circles are also symmetric with respect to the y-axis. And we'll set a distance between the center of these two half circles. We'll set that distance to 18 millimeters. We've got 4 degrees of freedom. We need to set the diameter of our circles. So let's set those to 2.8 millimeters. And it looks like we need to make both of these circles equal to each other. We should do the same for the 2 arcs. We'll make them equal to each other. And now we will set the diameter of this arc to 3.5 millimeters. Okay, so at this point, our sketch is fully constrained, and we can close it. And we're going to pocket these shapes that we just created so they go all the way through this bracket. And so we're going to pocket it to a depth of 12 millimeters, which is the width of this bracket. Now, next we're going to add a feature on the front that's going to give a little bit of rigidity to the TitanBot. And so this will become more clear as we build out the TitanBot, but this feature here needs to reference the top and bottom of the bracket, and it's a fairly simple feature. It's just a rectangle here. We're going to make this rectangle symmetric with respect to the y-axis, and we're going to give it a width of 7 millimeters. And we're going to add this feature out to a depth of 7 millimeters. And now we need to create a couple of channels on the front of the bench. These channels are going to allow wires to pass between the bracket and the battery rack that we build later. So select the back face of the bracket and create a new sketch. We need to reference the edge of the bracket. And we're going to create 2 squares that are coincident with our reference line. We are going to make these shapes symmetric with respect to the y-axis. And we're going to set the length of both of them to be the same. And we're going to set the height of both of them to be the same. And now that we've done that, we are going to set the length of our shape to 5 millimeters. This is to accommodate the width of the wire bundle that we're using. And we're going to set the overall height of this shape to 2.5 millimeters. Last, we need to set the feature with respect to the edge of our bracket. So we're going to reference the edge of the shape and the edge of the bracket, and we're going to set that to 6.5 millimeters. Okay, so at this point, our shape is fully constrained, and we can close out of it. And we're going to pocket all the way through this part of the bench, and it's an 8 millimeter high bench, so we will pocket it for 8 millimeters. And that will clear the wire channels. And we now also need to add a wire channel at the very top of this bench that's going to be used for accommodating our switch wire. So we're going to reference the mid part of the bracket. We're going to reference that bottom edge of that feature we just created. And we're going to create a square. Now the square wants to connect with the y-axis. So we're just going to make it too big. We are going to grab the bottom edge of the square and the magenta dot there, and we're going to constrain those coincident. And now we can take and bring in the edges of our square, or rectangle. We'll make it symmetric with respect to the y-axis, and we'll set the overall width of this feature to 2.5 millimeters. And now we're going to pocket this feature. We'll use the default depth of 5 millimeters. And our shape is done. We're going to 3D print 2 of these. They will hold a sensor for each of the front wheels. The second copy of this will hold a sensor for each of the back wheels. And our battery rack will screw right to these, and when this is bolted down to our base, it will also hold the battery rack down to our base.